Hey, trigonometry class. We are looking at section 1.2, angle relationships and similar triangles. We're going to be looking at some geometric properties and triangles, similar triangles to be exact. So here are some geometric properties that we should know. Vertical angles have equal measures, and here are what vertical angles are to remind you. You could see that um, this marking right here, the one in blue, and then the one here in blue again, those two angles are vertical angles. And then the ones in kind of a red color are also known as vertical angles. Each pair of vertical angles are equal in measure. Okay, so whenever we have parallel lines and then this line going through those parallel lines known as the transversal, we have some properties that come about, and that's what we're going to look at. I'm going to look at some angle relationships, and these are the angle relationships. We have four of them that we're going to look at. Here's one of them, alternate interior angles. Are right here. Notice that here's the parallel lines, and on the inside of the parallel lines, so in between these two, that's why it's called interior. We're looking at angles that are on the inside of the parallel lines. They're on the opposite sides of this transversal, so that's why they're called alternate interior angles. And when we have parallel lines in a transversal, these alternate interior angles are equal in measure. Same thing goes with alternate exterior angles. They're on the exterior of the parallel lines and on the opposite sides of the transversal, so hence the name alternate exterior. These angle measures are also equal. Now, interior angles on the same side of the transversal, known as consecutive interior angles, or same side interior angles, these will actually add up to 180 degrees. These are supplementary. And then corresponding angles. So corresponding angles are angles that are in the same position as each other. So angle 2 here and angle 6, they are in the same position. If you were to separate these two parallel lines out, they are in the same position, angle position as each other. These angle measures are also equal to each other. Now, in this one, it says find the measure of angles 1, 2, 3, and 4, given that the line M and N are parallel. Okay, so here we go. We have angle 1 is equal to this right here, the 3x plus 2, and angle 4 is equal to 5x minus 40. Well, if you remember, okay, we have parallel lines and a transversal. 1 and 4 are alternate exterior angles, and these two angle measurements are equal to each other. So we can set up the equation. Let me get my pen out. We can set up this right here, that 3x plus 2 is equal to 5x minus 40, and solve this equation here. So we're going to get 42 is equal to 2x, and x is equal to 21. Now, if we plug x back into either one of these, we'd end up with the same thing. So measurement angle 1 and 4 are equal to each other. And that is equal to 65 when you plug it back in. Okay. And we're going to disappear again. There we go. All right. So also 1 and 3 are vertical angles. So they are equal to each other. We can add to this right here, the measurement angle 3 is equal to the measurement angle 1, which is equal to the measuring 4, which is 65 degrees. Now the only angle measurement that we're asked to find that is different from all the others is angle 2. And angle 2 and angle 1, they are supplementary, meaning they add up to 180. So subtract 65 from 180 and you've got the measurement of angle 2 is equal to 115. And there, we're done with that one. Okay, let's look at this next one. So in this problem, we are asked to find the same thing, angles 1, 2, 3, and 4. And in this problem, 2 and 3 are supplementary angles. They add up to 180 because they are consecutive interior angles to each other. So we're going to set up an equation again, just like we did in the last problem, like this right here. I'm going to say 9x plus 9 plus 7x minus 5 is equal to 180. So solve this equation and you will end up with, let's see, 16x is equal to 176. So x is equal to 11. Now, if we plug 11 back in to this one right here, we will find that the measurement of angle 2 is equal to 108 degrees. And then for angle 3, do the same thing, plug 11 into this portion right here. We will get the measurement of angle 3 is equal to 72 degrees. Notice that these 2 degrees add up to 180. Now, angle 1 is going to be the same as angle 2, actually, because they are vertical angles. So angle 1. And actually, angle 4 is also going to be equal because those angles, angle 1 and angle 4, are alternate exterior angles. Those equal 108 degrees. Okay, so we're done with that one. Now, angle sums of a triangle. We should know that that all interior angles inside a triangle are going to add up to 180 degrees. So looking at this right here, we're going to say that the measure of 2 of the angles of the triangle are 48 degrees and 61 degrees. Find the measure of the third angle. So with that triangle sum theorem, we can figure out what the measurement of that third angle is going to be. So here we go. Let's say 48 degrees plus 61 degrees, whoops, plus x. I'm going to get a better pen, guys, for this thing. Okay, is equal to 180 degrees. All right, so when we add up all of this, there, we get, let's see, 109 degrees over here plus x equals 180. And then subtract that 109, you get 71 degrees. So x is equal to 71 degrees. Now here we have types of triangles. by angle measurement. The by angle measurements, here's an acute triangle. All angles in an acute triangle are acute. And then when one angle is a right angle, it's called a right triangle. And then when one angle is obtuse, like this one right here is obtuse, we have an obtuse triangle. And then types of triangles by sides, we have this right here. All sides are equal. We have an equilateral triangle. And then when two sides of a triangle, like this side and this side, are equal, then we have an isosceles triangle. When no sides are equal, we have something called a scalene triangle. Okay, we're going to be looking at similar triangles next. So for two triangles to be similar, here are their conditions. So if two triangles are similar, their corresponding angles must have the same angle measure. And also, their corresponding sides must be proportional. That is, the ratios of the corresponding sides are equal. So in this first example about similar triangles, it asks us to do this. It says in the figure triangle DEF and GHI, they're similar. It says find the measure of angles G and I. Well, here are the corresponding angles marked with their little markings here. This one is marked with 1. So the corresponding angle for D is G. So this angle right here, G, is also 53. So I'm going to say this right here. Angle G measure of angle G is equal to 53 degrees. And then also, since this sign right here, F and I, are also marked with the same markings, these are corresponding angles and they have the same angle measurement. So the measurement of angle I is equal to 29 degrees. And we're done. Now on this one it says, this also deals with similar triangles. Given that the triangle MNP and triangle QSR are similar, find the lengths of the unknown sides of triangle QSR. All right, so going along with knowing which angles correspond to which angles, we should know which sides correspond to each other. And the QR and MP, these two are corresponding sides. So what we can do with those ratios, or those sides, is set it up as a ratio. We can say, let's do to figure out all the other sides. We can say 12 over 8 is equal to, and now we can say something like QS over NM, which is 10. QS over NM, which we know to be 10. Now, figure out that and do cross multiplication or whatever multiplication you want to do there. And we should know that that is equal to, let's see, 120 over 8, which is 15. No, let's see. Yeah, 120 over 8, which is 15. So QS is equal to 15. Now do the same thing. We know the two sides that correspond, the 12 over 8, and that is equal to, let's say, the RS over PM, or PN, sorry, PN. which is 12, RS. So 144 over 8, RS, is equal to, let's see, what is that calculation? 18. There we go. We figured out those last two sides of this bigger triangle from knowing that they are similar. Okay, our last example is this one right here. We are finding the height of, well, it says a flagpole, but actually this is a tree. So what we're going to be doing is saying, it says, Joey wants to know the height of a tree in a park near his home. The tree casts a 38-foot shadow at the same time that Joey, who is 63 inches tall, casts a 42-inch shadow. Find the height of the tree. Okay, even though that these are in inches and this is in feet, we don't have to do any conversions for this one. We don't have to convert it into feet and inches or inches to feet or anything like that. As long as these two measurements are in inches and these two measurements are going to be in the same thing, we don't have to do any conversions. Just trust me on that. If you want to figure that out for yourself, go right ahead. Do your conversions. But here, again, we're dealing with similar triangles. And the way we're going to do this one is a lot like we did the last one to figure out the other two side lengths of the triangle. Well, we're going to figure out the last side length of this triangle. So we have this right here is x feet, and that's what we're trying to figure out. But we know that this person is 63 inches tall, and his shadow is 42 inches. And we know the tree is x length tall and casts a shadow of 38 feet. Solve that equation right there. And when we do, let's see, what do we get? We get that x is equal to 38 times 63 over 42, which is equal to 57 feet. And we are done. And actually, we are done with the slide too, the whole lesson too. This is the last thing we're going to be looking at is similar triangles. If y'all have any questions about this, ask me tomorrow in class, please. And I'll see you later. Goodbye.